So this is the second set of past paper questions, multiple choice on the alkanes topic. A few questions to work through. I'm going to recommend you pause on each one and then check the solution. So with that in mind, here is question 1. And this is a very, very important series of facts that you need to learn, not only to answer this question, but to answer other questions as well, because all of these are catalysts that you are going to need to be familiar with. So for example, concentrated phosphoric acid, not correct for catalytic cracking, but it is correct for the direct hydration of ethene with steam to make ethanol. Iron is used in the Haber process. Wrong answer here, but correct for a different question. And nickel is used in the hydrogenation of alkenes, and you'll also come across it in year 13 in a different hydrogenation reaction. Now that leaves us with zeolite, and you do have to remember that zeolite is the catalyst used in cracking. Next question. So which correctly represents an incomplete combustion of pentane? Well, in the first instance, they are all pentane, so that's absolutely fine, but we want incomplete combustion. So I've highlighted where the products of incomplete combustion are evident. It can't be A, this is complete combustion. We've made CO2 and water. What I can then do is disregard D, and I'm going to remove D because we don't make hydrogen as a product of combustion, be it complete or incomplete. If there was so little oxygen that we couldn't make water, we would actually be left with unburnt hydrocarbons. And then we look at which of the others is correct, and this simply comes down to the balancing, and it's the correct number of O's if I use 6O2 rather than 8O2, so the correct answer is C. Next question, and you'll note the typo here, it's a lowercase l rather than uppercase. So this question is asking about what will happen propagation step with an excess of chlorine in the presence of UV light. The UV light tells us that the chlorine will break down into its radicals. The excess tells us something about multiple substitutions. So I'm going to get rid of hexane. I'm not going to get that as a major product because we're more likely to find chlorine being added on. You're not going to get an H radical. It simply doesn't happen. So we can disregard that straight away. So we're then judging between C3H5Cl and C3H6Cl2. Well, the one with 2 Cls does imply multiple substitution, which is more likely when you have a lot more chlorine. Correct answer is C. On to the next question. And it's very difficult to find extra things to say on this one. It's simply a matter of knowing what does contribute to the greenhouse effect and what doesn't. And the one that doesn't is nitrogen. On to the next question. So which molecule is not produced when ethane reacts with bromine in the presence of UV light? Well, we want the one that's not. That's important. We're focusing on the wrong answer, essentially. The wrong one is the right one. Now, could we make D, C4H10? We absolutely could, because we're going to end up with ethyl radicals. And if 2 of those join together, we make C4H10. If I then look at HBr, that's one of the products in the standard mechanism that we look at. And I've given an example that we can see there. And if I look at C2H4Br2, well, it's entirely reasonable. We could end up with a CH2Br and a CH2Br combining to make C2H4Br2. The correct answer is therefore C. And remember, we don't get hydrogen radicals. We're very, very unlikely. Well, actually, no, we're simply not going to get hydrogen made. Next question for you. So on this one, we have C14H30 tetradecane. It's heated to a high temperature. It decomposes. We get 1 mole of hexane and 3 more molecules. So the tetradecane, all of them are correct in terms of the reactant. There's nothing to distinguish there. If we then move on to one molecule of hexane and 3 more molecules, in A, I've got C4H8 and 2C2H4, that's 3. In D, I've got C2H6 and 2C3H6, that's 3 moles. But in B, I've got C6H12 and C2H4, that's only 2 moles, so I can disregard B. If I then look at the balancing of the equation, on the right-hand side in A, I have 14 carbons, perfect. I also have that in D, so we're coming down now to the hydrogens. And actually, if I count up the hydrogens in the equations as they are balanced, I have 30 in A, I have 32 in D, therefore we can disregard D. The correct answer is A. And moving on, final question here. The least likely reaction to occur. I've spoken about this a number of times in this video and the previous video. The big giveaway here that makes it a very quick answer to a very quick question is this hydrogen radical. It simply doesn't happen. For that reason, the correct answer is B. That takes us to the end of this video. Thank you for listening and goodbye.